Welcome to Ask and Learn.
So we have a satellite which is orbiting around the Earth in an elliptical orbit. So we have an elliptical orbit satellite moving around the Earth, and here is the Earth, and the distance is, as shown in the figure, is 8230, and the same distance here also from the center is 8230. It says its speed at the perigee is 8650 meters per second, which means at this location speed is given. Use conservation of energy to find out the speed at B, which is at this location. And also the speed at apogee, which is the farthest point from the Earth at this location. So we'll make B right here in the center, and we'll draw a line like this. And this distance is 16,460 kilometers. So we'll use the conservation of energy and equate the energies at A and B. But first of all, we need to calculate the RB distance, which is the distance from the center of the Earth to the location B. So we have RB is equals to square root of 13,900 squared plus 8230 squared. So that's the distance of RB, which is this distance is actually given as 13,900. So we can actually find out the distance RB, which is the distance from the center of the Earth to location B, from this to location B, this distance, which is RB. So if you solve that, you will get 16,150 kilometers as the distance RB. Now applying conservation of energy, EA is equals to EB. No external forces acting on the system. The kinetic energy is half mVA squared, and the potential energy of the satellite in the orbit at A is minus gmEm by R. That should be equals to the kinetic energy at the point B, half mVB squared plus minus gmm E mass of the satellite divided by RB. And that should be equals to RA in this location here. So if you solve that, you will get VB is equals, VB squared is equals to VA squared plus 2 GM E 1 over RA, 1 over RB minus 1 over RA. Is simply by rearranging this, we can get this equation. And if you plug in the values of all, then we'll get 5220 meters per second. So that is the answer to our A part. Now we need to calculate at the point C. So we'll calculate the energies at EA and EC. But noting the fact that RC is actually equals to 16,460 kilometers plus 8230 meters. So that is equals to 24,690. Using the same approach, we can actually calculate the energies at the velocities at these two locations, again by equating the two velocities, the two energies, basically what I mean to say here. So we will get EA is equals to EC. And then using the same approach as we have used earlier, you'll be able to get VC squared is equals to VA squared plus 2GM 1 over RC minus 1 over RA. Basically the same problem, except that the RC is different here. If you plug in the values, you will get 3190 meters per second as the velocity at the point